Okay, we're told that ABC is a right angled triangle, which means that ADB is a straight line. And that's important because unless you know that for sure, you can't assume that that to that to that is a straight line. This might be off slightly. Anyway, we have to work out x. Now, I'm going to show you two different approaches. The first one, we're going to focus on this smaller triangle here. We want that angle. We know that this side is 5.2. So if we knew this side, we could use sine cos tan to work out the angle, because then we'd have two sides and the angle. So let's do that. We need to work out BC. To do that, we need to look at the big triangle, because we know that side and we know this side. This side is 10.4 plus 5.2, which is 15.6. So we can use Pythagoras' theorem to work out this side, because we know that and that. So let's do that. Pythag says that the big side squared is that squared plus that squared. So 18 squared is equal to 15.6 squared plus, we need a name for this side. Let's call it, well, we're not going to call it x, which is the go-to symbol, because we've already got x. So let's call it something totally different. How about q? Okay. So 18 squared is 15.6 squared plus q squared. Okay. Therefore, we want q squared by itself, so bring the 15.6 squared over here. So minus 15.6 squared from both sides. And we get 18 squared minus 15.6 squared is equal to q squared. Okay, therefore q squared equals 18 squared is 324. 15.6 squared is 243.36. Therefore, q squared is, that minus that is 80.64. Therefore, take the square root of both sides. Square root of q squared is q, is square root of 80.64 is 8.979 something. Something. Okay, put that number in your calculator's memory. You have to use the whole number for subsequent calculations. So make sure you know how to use your calculator properly and get that in the memory so you can recall it later. Okay, so q is 8.979 whatever. Right, so now we've got two sides of this little triangle and the angle, so we can use sine cos tan. So we have a very bad 10. Okay, x 5.2 and 8.979 something. That's a right angle. Right, first thing, label the sides. The longest one is always the hypotenuse, the one opposite the right angle. The one opposite our angle of interest is the opposite, and the one touching the right angle and the angle of interest is the adjacent. Okay, so we don't have the hypotenuse, we know the opposite and the adjacent. So the one that connects the opposite and the adjacent is tan. Tan of x is the opposite over the adjacent, which is 5.2 over 8.979. Therefore, tan of x is 5.2 divided by 8.979. And remember, you're going to use your memory recall on your calculator to get that whole number, to get the calculation exactly right. It is, where the bloody hell is it? 0.579 something. Something. Again, get that number in your calculator's memory. Therefore, if the tan of x is this, then to get the actual angle, you have to use the inverse tan function on your calculator. It's the inverse tan of 0. And then you use your recall function to get the whole number. Therefore, x is, in your calculator, inverse tan of that is 30.073. Something again. And they want it to one decimal place, so the final answer, x is 30 to one decimal place. That 7 pushes this up to a 1, so it's 30.1 degrees. There you go. That is x. Right. Now, thank goodness I don't have to use this bloody orange pen anymore. I'll show you the other way to do it. Let's hope the red pen is slightly better. The other way of doing it is looking at the whole triangle and treating this whole angle as 1. Okay? So we have to label the whole triangle using adjacent, opposite and hypotenuse. So the whole thing, the hypotenuse is the one opposite the right angle, so that is the hypotenuse. Here is our angle. The one touching the right angle and your angle is the adjacent, so it's 8.979, but if we were to do this method from the beginning, we wouldn't know that. So let's pretend that we don't know what this side is. And the side opposite the angle is the opposite. Right. Again, we're going to use sine, cos, tan to work out this whole angle. So what have we got? We know the hypotenuse, we know the opposite. Remember, we don't know this because we're pretending we haven't done this method already. So we want something that connects the hypotenuse and the opposite, and that's sine. So sine of the angle has to be the whole angle, and the whole angle is x plus 30. Sine of x plus 30 is the opposite over the hypotenuse is sine, so the opposite is 10.4. And the hypotenuse is 18. Okay? 10.4 divided by 18 is did you spot my deliberate mistake? It's not 10.4, is it? It's 15.6. It's stupid. 15.6. That's much better. 10.4 is only up to there. Right. Oh, idiot. 15.6. Right. So the opposite is 15.6. The hypotenuse is 18. At least I got that right. So 15.6 divided by 18 is 0.86 recurring. Okay? Again, put that in your calculator's memory. Therefore, if the sine of x plus 30 is 0.86 recurring, then whatever that is, which is x plus 30, is the inverse sine of that. So the actual angle, which in this case is x plus 30, is the inverse sine of 0.86 recurring. Okay? Therefore, x plus 30 is inverse sine of 0.86 recurring is 60.073. Something, something, something. Good. Therefore, you want to find x, so take the 30 over here by subtracting 30 from both sides. Therefore, x is 60.073 minus 30 is 30.073. Something, something, something. Which, to one decimal place, the 7 pushes that up to a 1 again, just like down there. 30.1 degrees. Okay. 2 different methods of finding it. Which is your favourite? Well, I think the second method is better. The only thing that might put you off this method is treating the whole angle as 1 until the end, using this x plus 30. Don't let that put you off. As you can see, all we had to do is subtract 30 at the end to go from 60 to the final answer. So it's fine. But if you use this method, that's also fine. It's up to you. They both give you the correct answer, as they should.